Hello and welcome wherever you are. Today we are going to look at a concept concerning salts known as water of crystallization. So what exactly is a crystal? Usually a crystal is a solid that will have a regular pattern or a regular shape. And what do I mean by that? It's because when you look at, for example, this salt crystal here, our table salt, sodium chloride, you'll find that it has these sharp edges. It's kind of like a cube, basically because of the way the ions in this crystal are arranged. They are arranged in a cubic form. That's why you'll find that our salt will tend also to be formed in form of a cube. But this does not mean that our sodium chloride contains water of crystallization. I just wanted to talk about a crystal. But what exactly is water of crystallization? This is the definite amount of water with which some substances chemically combine to form crystals from their solution in water. Now, some substances, as they are crystallizing, they tend to crystallize with some water incorporated in their crystal lattice. The previous image we have seen is a crystal lattice of sodium chloride. However, even other substances like we are going to see, they also contain different ions that are well arranged respective to one another. For example, when you look at copper 2 sulfate, we shall see that copper 2 sulfate, when it's hydrated, it will incorporate those water molecules within itself. So these kind of compounds are usually known as hydrates because of the water. Something hydrated usually contains water. So if you hear the word hydrate in chemistry, it basically means there is some water of crystallization present. Or we can also call it water of hydration. But the key word, usually this amount of water is definite. It is fixed. It can be 2, it can be 3, and so on. So some examples of water of crystallization, we have calcium sulfate, 2 water. So we put a dot between the formula of the compound and then the water molecules that are chemically bonded to our compound. So it means that in our crystal lattice of calcium sulfate, we have 2 water molecules that somehow find their way and bond within those given ions or atoms of calcium sulfate. So this dot means the 2 water molecules are somehow chemically combined to the calcium sulfate. We also have copper 2 sulfate, 5 water. At least this one is quite common in our chemistry setting because we know it's well used in testing for the presence of water. So what usually happens whenever these compounds or substances that have water of crystallization are heated? Obviously, water and heat are kind of arch enemies or rivals. So whenever we heat calcium sulfate, for example, 2 water, it will decompose to form calcium sulfate plus water vapor, which is our steam. So it will drive off, and then we shall find that our hydrated calcium sulfate, that is to say the one that contains water of hydration, it will now become anhydrous. So from crystalline, these are crystals, we shall see it becoming amorphous, kind of like powder. Let me just use powder. So we shall see crystals becoming powder. So usually this is what happens whenever we try to heat water of crystallization. And the same applies to copper 2 sulfate. Let's have a look at copper 2 sulfate. Here we have 2 dishes where we have our, this is hydrated copper 2 sulfate. I'm sure you're well conversant with it. While this is our anhydrous. Usually it's kind of like white. As you can see, this is more of powder-like. It's like powder. This is amorphous. The solid particles don't have a regular shape. But if you can look at this image here at microscopic scale, you'll find that these are more of crystals. They tend to have regular outlines. So what happens when we heat copper 2 sulfate, this hydrated copper 2 sulfate, 5 water, obviously it will lose its water of crystallization such that it forms our anhydrous copper 2 sulfate. And the reverse will be true, that if you add some water to it, it will form back the hydrated copper 2 sulfate. And that is the logic behind the test for the presence of water. So there are very many other examples of compounds that show water of crystallization, but still one thing to note, we always have a dot between the formula of that substance plus the water of crystallization. The number before shows the definite amount of water that is required for the crystals to form. Another example, we can have calcium chloride 6 water, sodium carbonate decahydrate, or 10 water, and so on. These are other examples of substances that show water of crystallization. Thanks for watching. For any question or inquiry, please let me know in the comment section below. Don't forget to like, share, comment, and subscribe. If at all you find this content useful, stay safe.